At our department, we are responsible of developing and operating serious games. Here are some examples of them. One of the biggest game in players is Codescape. We have about 3,000 students playing it every year in mostly introductory programming courses. As a motivation, wanted to leveling differences in programming experience. We do a self-assessment. The students do self-assessment every year before the semester starts, and you see we have a lot of students in the middle, but also students with absolutely no programming prior experience, but also experts. So we wanted to help with novices and offer a game where they can play unsupervised with their own speed, with replayable labels, playful small steps, and to lower the barriers for them so they don't need to install. So the game is browser-based. And in the game you're a passenger on the spaceship traveling to a distant planet. And then something happens. You wake up, no air. You can escape this cryogenic capsule. You can only program this small robot dog, and the robot limited memory. So this is a game level, as a screenshot of game level. You see the command limit on the bottom. For this level is 17 commands. And you have to navigate through the level. At the right of the map you see two circles. This is escape teleporter. You have to activate it somehow. So you have to find out how. And maybe it's a red button, maybe it's so we have different items here. Interactive, and you navigate the robot through a programming. You put a program in an editor on the right, and the errors you get on the bottom right in the error console. So most of the game consists of these levels, but there are some concepts, programming concepts we can map as a level. So we have also tasks like single choice, drag and drop, and for some programming concepts they create so-called mini games. There, you, for example, on the right you see Boolean logic formula. You have to falsificate so the laser is so disable the laser and the dog can come through. These levels and tasks we combined in decks of a spaceship. And the deck represents one homework. So it depends on the use scenario. Sometimes we enable all decks at once, so students can play all game at once. But mostly the game accompany lecture, so the decks are enabled with the lecture progress. For the game, this is a browser-based game. We use HTML5. And Phase.io game engine for the movements of the dog. At the server side, we use Docker to compile and run the programs. We use Entler parser to parse and analyze the submissions of the students. We use Maria database to save the submissions, and for the website we use PHP framework. So game is developed in 2016. First only for Java. Now we use Docker and can process almost every language if we are an Entler grammar. But we still have to create content, so we have content for Java, Python, Julia, C, and JavaScript. And we operate the game mostly in introductory courses, but also at some schools, mostly as part of the homework. So content depends on the lecture. But we also have some events like Girls and Boys Days at our university, and they use this game, and they have also standalone usage in a museum. This game is an example of a serious game from our university. Learning scope, We have content for basics, languages, variables, loops, control structures, arrays, functions, recursion, lists, and trees, and sorting algorithms, and more algorithms. What we are missing is object-oriented content, because we need also to create the content, but also change the interface of the game. So we need many editors for many classes, many robots. It's possible, but we have still to work on it. In the game, we have also a survey. We ask the students to rate the game. We have more questions here, so there are only 5. The game gets very positive feedback. We also get emails like, "I'm not in the course, please let me play too." We have 2 questions where we have not very good rating. It's about level understandability, and here we're still to work on it in lecture integration. In this case, it was because we don't have this object-oriented content, and they also use Haskell and Prolog to programming languages. We don't have content for this. Because of a lot of data, we are inspired to do research, not part of this paper, just to mention. We try to analyze the strategies, problem-solving strategies students are using in the game. And in this case, we also combine this data with eye-tracking study. So the players play our game in a lab, and we have a scarf plot representing this data, and under the scarf plot we have data we collect through the game itself. So, as a conclusion, we operate the game since 2016, mostly with positive feedback. We're still working on the game. We improved modularity, so we can fit with a lot of different operation scenarios. Now we use Docker, so we can support a lot of different languages. But the main future work is in creating content, so we hope we will have time for this. Object-oriented programming, new programming languages, and we would like to improve the feedback. And one big wish, we would like to do a better user experience to level creation, so the level editor. We have one terrible user experience in the backend, so we would like to do it better, so the students can create their own levels. So thank you.
That was very fast.
I was afraid. I trained for 15 minutes.
Good, but then we have time for some questions. Any questions? Not I will say. But the UI experience for game level creation, I know that has been a challenge for a long time. How much resources do you intend to put into that?
Yes, I think we need to find a good designer. We have to put a lot of work ourselves first, of course, but then also to test. So the problem is we understand how to create a level, and we don't know what the students don't understand. Maybe also this eye-tracking study will help us. So this is the idea. So we put maybe 1 or 2 designers on it, and all team together try to do it better.
Have you thought on collaborating with someone coming from, let's say, other field in order to understand the challenges in why students don't really understand or learn?
Yes, that's a very good idea.
Yeah. Good. Mats has a question.
Yeah, I was just wondering, this idea of the level creation, is the intention to create levels that other students then have to write code for the boss? Have you thought about doing it the other way around, where you give people a program, so the challenge is working in the level editor, so they see a program and then they have to create a level where the bot can survive if it has driving that program? Is that an idea that might be useful, or have you thought about it?
We thought about different types. For example, also levels for example, for object-oriented stuff there. At the first, they can't program. They just have to see, okay, everything is an object, and I can click on the dock and see the position, for example. I changed the position. And then the next step, I saw, okay, this is objects. Now I can also program them. So we thought about different types of levels. Yes. But also we didn't.
Because I think it is a challenge. Any more questions?
I have one.
You have one? Yes.
Yes. You mentioned that the program was meant mainly for as homework for students. Which kind of considerations did you do when developing the game to make it fit better for homework and kind of the unsupervised learning instead of alternatively using it in
They have this flipped classroom idea in a lot of lectures. So this was, we have also a lot of different games. So we started with our different game and combined everything together. So they have flipped classroom, they have a video, so they're looking. And then they also play a game at home all together. And after this, we also did the same for this for programming. So it was successful. So it was a business simulation game. And okay, we do the same again. Yes. And the second problem is we have a lot of students, and so we have a problem with supervising. So,
But then the student supervised learning would be a good idea in principle.
For sure.
Yeah.
Thanks.
So, thanks a lot again.
thank you.
Then we have an hour of coffee break and posters.
Yes. Thank you, Gamper. I just wanted to say with the posters, so we've discussed this a little bit in the organizing committee, and the scheduled break we have now is 1 hour and 20 minutes, which I think is too long.
Yes.
So we were going to propose to just instead have a 40-minute poster and coffee and demo break. So coming back here in 20 minutes to 4, and then simply running the next session, according to that schedule. Is that okay for everybody?
Yes.
Do you want an even shorter break than 40 minutes? What, 30-minute break? 30-minute break. Okay, 30-minute break. Okay, so super fast coffee demo and posters, and then back here in half an hour.
Yes. I was working with her in a different project. Yeah.